Today, I'm going to talk about what we have done at Galul Risk to build our risk reporting solution and how it works, and what are the benefits for us of using MATLAB. So let's set up the scene. The global investment management industry requires reporting with increased transparency and substance. We have seen throughout the years that the processes employed are costly and inefficient, and they would benefit from a higher level of automation. This is why at Clarus we have built an end-to-end automated and customizable risk reporting solution. Our mission is to automate portfolio risk and regulatory risk to provide operational efficiencies and promote transparency. Our key differentiator is that we offer a fully automated end-to-end solution that delivers high-quality, fully customizable risk reports across multiple asset classes. And what is important for us is the flexible reporting. The analytics included and look of the report are completely customizable so that reports can meet the specific needs of different readers, boards, regulators, and investors. For example, here on the right-hand side, I have two screenshots of two different report types that we can produce. So now that I have explained who we are and what we do, let's take a look at how our solution works. The process consists of different steps. The first one is getting data from the client, which comes in different ways and in different formats. Then we clean the data, possibly the most important part, and produce standard files for positions, NAV, balance sheet, shareholders that are loaded to our central database. The data is enriched using data feeds from different data vendors to construct our data in our database, the market data table. With market data and other data like benchmark, FX, price history, etc., we construct a set of analytics and risk calculation that will be the core part of the report. Finally, depending on the client, a different report is created with results and graphs that interest that client, and it is sent automatically to them. So let's go a bit in more detail in the different steps. The first step is getting the data. Data is received via SFTP or email, or directly loaded by the client to a web portal. Data is not clean at all. It arrives in different formats, and it can also be encrypted in different ways. We have a set of reader classes that know how to read the client-specific data and convert it to something standard. For us, it will be CSV files that they look something similar to what I have in the screenshot. It is position data, so we will need some tabular data where some columns are strings and some are numbers. The reader classes use MATLAB code, object-oriented code, which allow us to have a good architecture that simplifies the code using abstract classes and inheritance. The reader classes will know what part of files need to be read and how for each specific client, and will do the data checking and cleaning. I have added some screenshots of how the abstract class and how we use inheritance as well. The clean data, those CSV files that I've talked about, are imported to our databases using DataFeed Toolbox, and enriched with DataFeed Toolbox to download extra data from different data vendors. With this data combined, we also add some derived data that we calculate to expand our market data table. So for example, we can calculate volatility or implied volatility for derivatives, modified duration and yield to maturity for bonds, etc. Depending on asset class, we have different extra calculations that we do and that we record. Once the calculations are done, the code automatically produces reports. These reports will have performance and risk compliance calculation, which is the core part of the report. We use different parts of MATLAB to do that. So we use core MATLAB for data management, using tables and dump tables and functions for dates. We use the financial toolbox for portfolio simulation and optimization, derivative pricing, and dealing with financial and business dates. We also use the financial instruments toolbox to compute derivative pricings and sensitivities, and we also use the econometrics toolbox for model simulation, hypothesis testings, etc. Here I have some screenshots of some of the plots and results of our risk calculations. So I have simple plots, like for example, a cumulative performance chart on the left-hand side, or more complicated ones with a fan chart of simulated portfolio performance using portfolio optimization and stress test results. I have added as well some tables produced by the MATLAB report generator that show the results of our calculations, so applying historical stress tests on the left-hand side, or at the bottom P&L analysis, or on the right-hand side bar and C-bar results. As I said, once the calculations are done, the code automatically produces reports. We have different report classes: performance, compliance, regulatory, optimization, and private asset. At the moment, for regulatory reports, we support PRIPS, Annex 4, and liquidity stress tests. So how does it work? We have a library of report parts and sections for each class of report. When we define a new report type of a given class, we select a set of parts organized by sections. Then we also define styles and colors and use the client logo so that reports look the way client wants. Finally, we use the MATLAB report generator to fill in blanks in our templates. Here I have an example of a part that would be part of a compliance report. This is a part for principal exposures, where we would have a plot and a table showing the exposure and the largest position. So the placeholder that you can see on the right-hand side with the grayish image is MATLAB will fill it in with a plot. And the placeholder that is highlighted on the right-hand side that has the name R principal instruments or something like this. It will be filled with a table showing the principal instruments. Each client has a report job for a specific report type and date assigned. When the data automatically arrives, and we do the steps I have mentioned in previous slides to create the content of the report, a report is created automatically. A PDF and an Excel spreadsheet with a summary of the calculations are then sent automatically to the client via SFTP or email, or they can be downloaded from a web dashboard that we have. Here I have an example of an email sending a compliance report to a client, where automatically the code also adds some summary that this client is interested in learning very fast. So in this case, there's a number of reportable long positions and a number of reportable short positions. And here I have a screenshot of the web dashboard where the client can download the report created, in this case a liquidity report, using the download button of it is shown by the little cloud with an arrow. What's interesting for us is the thing that given a set of data from a client, we can produce multiple report classes and types for them. For example, I have here a screenshot of a compliance report for a given account, where you can see summary of tables with the compliance status in green, or in this case there are 2 warnings, and some of the results and tables, plots, etc. that we add. And for the same client, we can produce a liquidity report because we have the data for it that contains different results and different plots. This brings me to the benefits of using MATLAB with an example, which is adding the liquidity stress test report to our suite of regulatory reports. Last year, in September, a new regulation came into effect, the ESMA liquidity stress test. For our clients that were in scope, we only needed some extra data to process, the shareholder registry data. So we quickly prototyped and implemented in MATLAB the necessary calculations for the liquidity stress test. We modified some report classes to be able to read this new data, the registry. And we did some research on different stress scenarios using historical data and created new parts in our template for the reports generator to fill in. So in summary, in weeks, we had a new report class and type ready to be sent to clients and regulators. So to summarize, our mission is to provide a unique and flexible reporting solution that enhances transparency and engagement with the stakeholders. Using MATLAB and an SQL database, we have built a complete end-to-end solution that allows us to automatically process daily data from clients, or as often as it comes, create multiple reports completely customizable to suit the client needs, and quickly prototype and add new research to our reports to enhance them. Here I have some information on how to contact us in case anyone has some questions. Thank you.
Thank you very much, Beth. So in this second part of the webinar, I'm going to show you a bit of the details involved in building a reporting tool like the one that Clarus Risk has just shown. I'm going to do it in two parts. So first of all, I'm going to show you an example on how can one build a report entirely within MATLAB. And after that, I'm going to show you a more production level example where we have a combination of MATLAB code plus external templates to have more control on the look and feel of the final output of the report. For those of you who are not familiar with it, this process uses something called the report generator, which is a tool that allows you to build different types of reports entirely within MATLAB. The way it works is you create a report object using the function that you see here on the screen, and you keep adding elements to this report object, or you keep stacking them with the right parenting structure until you complete the report. Once you're done, MATLAB will automatically generate the right object. So there's four types that are supported. One create HTML files, PDFs, docs, or HTML templates. So in this case, let's just start by creating a sample website. The way it works, you create a report object, and in this case, it's going to call my new key information document, and the type is going to be HTML. So when you initialize the report, you get this report object. And again, MATLAB is still not creating anything. This process is usually quite fast. It's just a few MATLAB objects loaded in memory. So within this report object, the first thing I'm going to do is I'm going to add a title page, for which I'm using the title page functionality of the tool. And you can customize the title page with a title, author, an image, and so on. And whenever you're done, the way it works is that you simply have to add it to the report. So in this case, my title is going to be my new KID report. The author is myself, and the publisher is going to be MathWorks. So let's add this to the title page. So in the same way that I added a title page, I'm going to add a table of contents. So the process is exactly the same. I create a table of contents object, and I add this object to the report. So now that I have the skeleton of my report has a title page, has a table of contents, I'm going to start adding data to it. I'm going to add two types of data. First of all, I'm going to add some static data, something that I have already in my computer. And then I'm going to add some data that will vary from customer to customer, and that will be dynamic from one report to the next. So in Report Generator, the way this works is as long as you can import the data into MATLAB, you will be able to add to the report. Hence, there's a bunch of functions like read table, SQL read, web read that are quite useful to import the data into MATLAB. For this first part, for the static data, I just have the data stored in a Word document. So I just need to grab this paragraph and add it to my new report. So for this, I'm using the extract file text function here, and then I'm splitting the text based on the new lines. So I separate title and the paragraph. To add this piece, what I'm going to do is I'm going to create a new chapter object with the title sample KID, and then I'm going to add the paragraph or the text to the chapter using the function add. Notice that I'm not yet adding the chapter to the document because I'm not done yet. So I'm going to delay that process until the very end. So let's create this chapter. So this was static data, right? My Word document doesn't change, so it's always the same. Let's now look at how a more dynamic process would look like. So let's assume that we have a client has sent us some information on 3 stocks where he wants a report. the data has come as an Excel spreadsheet, so we use read table to import data into MATLAB. And we see that this client is quite worried about what these raters are looking at. So we need to report on GME, on AMC, and there's also a FTSE 100 stock called RSA, which is undergoing a merger. So maybe quite interesting to see what's happened. So what I'm going to do for this report is I'm just going to pull the latest stock data for each of these three products, and I'm just going to build, just going to put it together inside the report. And for this, I'm going to use some public data feeds. Within MATLAB, so you can use many different data sources for this purpose. The only thing to take into account is that when working with financial data, oftentimes you end up working with time series, and especially in cases like this one, where you have securities that belong to different markets, managing the dates is quite important, as these markets might not have the same opening days, right? So in this case, it's a very clear example. The first two belong to the New York Stock Exchange. The last one is the FTSE 100. So the holidays might be different, working days might be different. So to make it robust, it's important to keep in mind functions like a busy date, holidays, and so on. What I'm going to do is let's start with GME or GameStop, and the start date is going to be 2 months from now. So first business date 2 months from now. The end date is going to be basically the next business date from today, and I'm going to get it for 2 months. Again, you can use any provider you want. If you were, for example, using Bloomberg, the way it would look like would be you create a connection to Bloomberg, you specify how you want the data to be returned. So usually timetable is the safe bet if you're working with time series in MATLAB. And then using the history function, I just want the history of the stock for the last few months, right? So you get something like that. And this will look exactly the same if you used something else like Yahoo, FactSet, Quandl. It doesn't really matter. Once you have the data imported within MATLAB, what I'm going to do is I'm just going to create a figure, right? So I'm just a new figure, and then just going to use the Kendall function to plot this data. I'm going to create a figure that looks like this, right? So where you can see clearly the effect of rate hat on the stock. I'm pretty happy with these results for this first stock, so I'm going to add these results to my chapter. The way I'm going to do it is I'm going to create a new section, and within the section I'm just going to create a figure. So all this is automated within the report generator function. So you can see that I create a figure using my figure handle, and then I'm going to add a caption and the height of the figure the way I want it. And then again, I'm just stacking the objects one on top of the other. So I'm going to add the figure to my section and my section to my chapter. I could perfectly add the figure to the chapter directly. The reason why I'm doing that is I'm going to show you how the table of contents organizes this very nicely as you organize your report. So we added GameStop, so maybe we can do the same for RSA. So we get the results, fairly flat stock as it's undergoing a merger. And finally, we can do it for, let me add the stock actually. And finally, we can do it for AMC. So let's just pick maybe just 1 month for this one, just to show you the difference. Again, we look at the stock, and if we like the results, we can just add it to the document. Now, so there's two things that I'm doing now. So first of all, as I pull this data from the public feed, I'm synchronizing the different timetables, so I can use them afterwards in a second example. So what I'm going to do is I'm synchronizing the results, and then I'm saving the data in the database using directly SQL write. If you use timetables in MATLAB, if you're not aware of function synchronize, it's quite useful. It allows you to simply merge different tables by date, right? So in case that there's dates in which in one timetable exists and the other one they don't, this function will automatically deal with it. And in this case, I made it obvious since AMC has 1 month less than the other two. So I'm saving the data for later use, and then finally I'm generating a report. So what are the steps that were left? So first of all, I'm going to add the chapter to my report, and then I'm going to close the report, and then I'm going to view what was generated. So let me make it full screen. So as you can see, is a website. It has a title, my name, company, the date of today. Since we added the table of contents, you have a hyperlink table of contents. So for example, you can go and see what actually got for GME, and we see we have the each of the graphics with the caption that we added for the last 2 months. Same for RSA, and then the same for AMC, where we only have one last month. Again, this process was quite straightforward, but now the question happens is like, how much would we have to change our MATLAB code if instead of generating a website, we actually wanted to generate, for example, a PDF, right? So this is pretty straightforward. The way it would work is that you would go to your code and you simply say that, okay, let's just change the type of the report to PDF, right? So in this case, if I simply rerun the entire thing, what we will get is just a PDF with the exact same information. So here it is. So this is my report. Let me make it big. We have a table of contents, and again, this is just pick the last one, which was the last one I did. If I go here, I get the chapter with the text, the figure, the caption, and so on. So in a nutshell, this is what report generator is about. It allows you to anything you can do in any of these supported document types, HTML, PDF, Word documents, you will be able to do programmatically within MATLAB. So you can completely automate the generation of reports and basically pull in whatever results you got in MATLAB, or you can import in MATLAB. In the second part of the talk, I'm going to show you a slightly different workflow. As you can imagine, building all the formatting in a programmatic way can be quite complex and can take quite a lot of time. And using templates can help you be more productive in building the report. To show you how one can use templates to become more productive, I'm going to build a report which is going to be composed of 2 blocks. The first one is going to have the same as before. It's going to be a report on the latest movements of the security. And the second one is going to be a financial analysis on one of these stocks. The main requirement for this report is going to be, first of all, I want these 2 blocks to be completely independent from one another because I want to be able to reuse them later on or in different reports. And the second requirement is going to be that I'm going to have quite a lot of formatting to my report, which I want to be able to control in a lot of detail. For the financial analysis, I picked here an example from the MathWorks documentation. I'm going to do a hedging using conditional variance portfolio optimization. However, you're not tied to this example or to this model. You can actually use any other model from the financial toolboxes, any model that you can build in MATLAB, or any data you can actually import into MATLAB. Very quickly, let's run this financial model in order to get the necessary data to put into a report. Now, first of all, I'm going to retrieve back the client data that we previously stored into our database. And for this, I'm using the function SQLRead. Recall that for AMC, we only queried the last month, and therefore the first half of the table is full of not numbers. Now, using the latest price for each of these stock, I'm going to use hedging using conditional variance portfolio optimization. And this problem is done in 3 steps. First of all, I'm going to simulate the price movements of the stock. Then I'm going to use a portfolio object to calculate the efficient frontier. And finally, I'm going to compare the conditional variance optimization with standard mean variance optimization to see how different risk measures lead to different results. Now, for the first part, to run the Monte Carlo simulations, I'm going to use here a geometric Brownian motion and the function simulate by Euler, which in combination allow me to very quickly simulate 100,000 different paths for this stock. And for this case, I'm starting with GameStop and the latest price on the market. Once I have the simulated paths for the stock, I can construct a portfolio using the stock plus a set of put options, which I'm going to price using a standard Black-Scholes model. For the purpose of this example, I'm going to choose 4 put options with strikes at 50, 75, 90, and 95% of the underlying price. And to price them, I'm going to use the built-in functions BLS price. Once I priced all the different put options for the simulated paths, in order to estimate the efficient frontier, I'm going to construct a portfolio object within MATLAB. For this case, since I'm doing a conditional variance optimization, I'm going to use a portfolio CVAR object, which is constructed using the asset scenarios or the asset price list. Then, once I have the portfolio object constructed, in order to estimate the frontier, I can simply use the estimate frontier function, which returns the actual efficient frontier for this portfolio. In addition to that, in order to compare the results, I'm going to construct a standard portfolio object, and I'm also going to estimate the efficient frontier on this portfolio, which in this case is going to perform a standard mean variance optimization, returning this different frontier for the same asset group. Now, in order to compare these results, I'm going to use the built-in area function to plot the weights at different return levels. For the mean variance optimization, I get a result where only the two strategies are used, the stock and the hedge at 95%, and these are a result of the stocks being highly correlated among themselves. However, for the conditional variance optimization, at the edges of the return levels, the results are obviously the same, but for the intermediate range of returns, the conditional variance has a much different result. Now, in order to build a report based on this analysis, we're going to use templates. In the previous case, we built both an HTML and a PDF report. So in this case, I'm going to use a Word document. However, the process is the same in all cases. So what we need to do is to build a template using Microsoft Word or the appropriate document type, where we put all the formatting or the static text, but we also leave some blanks, which will be later on filling directly from MATLAB. In Microsoft Word, in order to add this blank, one can go to the Developer tab and then select Add Control. And there are many types of blanks depending on what type of object we will be using to fill these holes. So in this case, I'm going to build two templates. This first one, to report on the latest movements of the security, is going to have a set of text objects or text blanks to fill the security information, and then a main graphics object to put the latest stock movements. Now, the advantage of these holes is that within their properties menu, one can specify a title and a tag, which will be what we'll be using directly from MATLAB in order to identify each of these holes. And on top of that, you can also select the formatting in which this text is going to be printed in the end. So then again, we build two templates, one for this the reporting of the stock, and then a second one specific to the conditional variance optimization. In the second one, we have two image objects and a few text holes that we'll be filling from MATLAB later on. In order to fill a template from MATLAB, there are two options. Option number one consists in creating a document part, and then within this document part, we can use the function move to next hole to iterate from one hole to the next, and then using the appropriate method in order to fill the information. The alternative, which is oftentimes more effective on a production environment, is to build a custom MATLAB class. And this MATLAB class has two requirements. The first one, it needs to inherit from a document part object, as this one. And the second requirement is that for each of the blanks that we had on the template, we need to specify a fill method that contains the instructions on how to actually use the MATLAB information in order to fill that hole. So for example, for the product name, we simply need to specify that we want to append the information inside to the report. So in this case, it's going to be append the string into the report object. For objects more complex, like an image, we also need to specify the width, the height, the caption, and so on. However, in the end, this means that for each of the template, we need to build a complementary class that contains the information on how to fill each of these blanks using MATLAB data. The advantage is that in order to fill a template from a class, we simply need to call the fill method onto an object of that class. For example, to build a report using these two templates, We do as before and we create a new report object with a title page and a table of contents. And within this report object, what we need to do is we need to add the two templates. So for the first one, we create an object of the class with the right arguments. So the fill methods have the necessary information to fill the blanks. And we fill the template and then we add the template to the appropriate section within the document. So this will be the first template that contains the stock information. So in this case, the closing price for the latest 2 months. In the same way, we need to do the same for the second template. We create a template object with the right arguments. We fill the template. We add the template to the section, and we finally, since this section is done, we add the section to the chapter. So now that the document is finally over, we can just generate the report, which returns a Word document with a single section for GameStop, which is composed of the two templates that we have stitched together using Report Generator. The first one contains some information on GameStop and a graphic of the closing prices for the last 2 months. And as you can see, some of the holes are filled with default formatting, but some others, like this one, are filled with very specific formatting, which was specified directly on the properties of the template. This first template is actually followed by the second one, consisting of the conditional variance portfolio optimization performed in GameStop. We added the two figures that were generated during the analysis, and at the very end, I added a table where I specified the risk of this product. This table was actually added entirely in a programmatic way within MATLAB, using the table object of Report Generator, but in the same way, it could be a table type object that was filled within the template. Finally, to summarize some of the key takeaways from this session, we saw that with MATLAB Report Generator, we can automate the generation of various types of reports. And during the webinar, we've seen Word documents, HTML, and PDFs reports, but this same process can also be applied to PowerPoint presentations. There's some slight differences in that case because PowerPoints work a bit different, but the overall concepts are the same. Secondly, we saw that there's two ways to generate the reports. One can do everything programmatically using entirely MATLAB code, or we can use a set of preset templates to aid in this process and help in the formatting and the configuration of the report. Finally, one important thing is that if one thinks of building a very robust reporting tool, it's very important that the whole process of processing the data and doing the analysis needs to be quite robust, since the report is oftentimes the last piece of a larger pipeline. And in order to reach the report, everything else needs to be completed successfully and in the correct format, such that the final set of data can be consumed by the reporting tool.